Alright, so in this video, we're just going to be talking about how to improve our math ability and specifically just what is the Pythagoras Theorem, how we can apply it, and I guess what kind of questions we might run into when we're looking at using this theorem. So what is the Pythagoras Theorem? Well, essentially, it's just this equation where c squared is going to equal to a squared plus b squared, and that is reflected on this right angle triangle. So the longest side of that right angle triangle, and usually the side that is opposite to our right angle, is the hypotenuse, and in the form of this equation, it would be the variable c. Between the other two sides, either side could be variable a or variable b, it's just really up to you. But we're going to essentially substitute in the length of those sides into our equation to solve for whichever unknown side we're looking for. Let's just jump straight into some questions. So these are two questions where we can pretty much just directly apply that Pythagoras theorem. Feel free to pause the video and try it yourselves, but we'll go through it together as well. To start, let's just write out the Pythagoras theorem or the equation. So c squared is going to equal to a squared plus b squared. Yep. So the longest side, or x, will be in the place of variable c. And let's just say that variable a will be 3, so 3 squared, and variable b will be 4, so 4 squared. We can square root both sides of this equation here. So we're looking at x is going to equal 3 squared plus 4 squared for square root. And this is, if we, I guess, expand, we're looking at the square root of 9 plus 16. And the sum of that is just the square root of 25. Square root of 25, as we know, is just 5. So we know that the hypotenuse of this right angle triangle is 5. So we're looking at a triplet that looks like 3, 4, 5. Let's come back to that, but let's go on to the second question. Feel free to try it yourselves, but let's do it together. C squared is going to equal to a squared plus b squared as always. The longest side in this triangle is 13, so we'll do 13 squared, and let's say the a variable will be x, so x squared, sorry, and then b will be 5, so 5 squared. 13 squared is just 169, and that's going to equal to x squared plus 25. Let's rearrange so the unknowns will be on one side of that equal sign, and the known numericals will be on the other side of that equal sign. So we're looking at x squared is going to equal to 169 minus 25. That, if we do the sum of the equation, we'll get 144. So if we square root both sides of this equation, we're looking at x is equal to the square root of 144, or x is equal to 12. This will give us the triplet 5, 12, 13. These are actually very common triplets, which when substituted into our Pythagoras theorem equation, will always work. So there's a bit of merit in, I guess, taking note of these equations. Let's move on. This is just what we've done in a, I guess, more neater, easy to read way. Let's try this. This is slightly harder. It's a step further because now we have two sides of our right angle triangle which have unknowns included, but we still approach it the same way where now we start with writing our equations. So we're looking at c squared is going to equal to a squared plus b squared. C variable will be the largest or the longest side of our right angle triangle, and that is x plus 4 in this instance. A variable will be x plus 3 squared, and b will be 5, so 5 squared. Another way to write this equation, just to read it a bit easier, will be x plus 4 squared is actually just equal to x plus 4 times x plus 4. The same goes for x plus 3 squared, and the same goes for 5. So when we expand this, we're actually looking at x squared plus 8x plus 16 going to equal to x squared plus 6x plus 9 plus 25. So let's rearrange this equation so all our knowns will be on one side of the equal sign, and our unknowns will be on the other side of that equal sign. So we're looking at x squared minus x squared, and we minus this x squared because it's moving to the other side, plus 8x minus 6x, same logic, is going to equal to 9 plus 25 minus 16, which is moving to the other side of that equation sign. So these two cancel out, and this would be 2x is going to equal to 18, and if we just divide both sides of this equation by 2, we'll get x is going to equal to 9. Oops, 9. So if we substitute x is equal to 9 back into our right angle triangle, we'll actually get a triangle that looks like this, where one side is 5, another side is 9 plus 3, or 12, and our hypotenuse will be 9 plus 4, or 13. So this, once again, produces a triplet, 5, 12, 13, which will always work when substituted into our Pythagoras Theorem equation. All right, moving on. This is just what we've done. This is an application question, but we're still using the same Pythagoras Theorem. So we have a farmer here who wants to build a fence around a paddock, and the paddock is just outlined with the red lines. And the question is just asking us, well, how much material is this farmer going to need to completely build that fence? And we're going to give our answer in meters. So this is our paddock. What this question essentially is asking us is, because the farmer wants to know how much material in total he's going to need to fully build that fence, they essentially just want to know, well, what is the perimeter of this right angle triangle? To find the perimeter, we need to know what all sides of this triangle are equal to. So first, let's start by just finding h. To find h, we know that because this is a right angle triangle, we can use the Pythagoras theorem. So it's going to be c squared plus a squared plus b squared. Well, what is our longest side? We know that the longest side is 17. So 17 meters long. 17 squared is going to equal to 15 squared plus h squared. H is the variable in this question, or the unknown in this question. So 17 squared is actually 289, and that's going to equal to 225 plus h squared. Let's rearrange. So our unknowns are on one side of the equation sign, while the knowns are on the other side. So you'll get 289 minus 225, and this is going to equal h squared is equal to 64. If we square root both sides of this equation, we will get h is equal to the square root of 64, or h is equal to 8. That is just one part of this equation. We know that h is equal to 8, but now we need to find the total length of this of the fence, or the perimeter of this paddock. So the perimeter, let's say, is just going to equal to adding all sides of this right angle triangle, and that should give us 40 meters in total, or 40 meters of material that the farmer is going to need to build his fence. Right, that is just the answer to that question that we've already done. That is all of the questions so far, but before finishing up, let's just look at, if we approach a Pythagoras theorem question, what should we do? Well, firstly, we need to know if the question, if using the Pythagoras theorem equation is actually going to be beneficial and actually help us when we're looking at a question. And if it is, then by all means use it. The next part is we need to identify what is the variable c, what is the variable a, and what is the variable b in the context of the question. We can correctly identify that given that the variable c is just your hypotenuse, or the longest side of your right angle triangle. Then that is pretty much most of the question just completely done. And the third step is just to accurately and efficiently, I guess, go through and substitute in your values and just rearrange and essentially solve for that unknown variable. Make sure to, because like I've said, there's actually a bit of value in trying to remember your your triplets or your two, 2, 3, 4, or I think it was our 5, 13, those groups of numbers that always work when we put them into the Pythagoras theorem. There's a bit of merit in remembering those. So when we actually go to do questions, and you can kind of notice that those are the numbers they're using, then you don't necessarily have to use time to solve and find whatever the unknown is. We can take an educated guess as to what x is equal to. However, if you do have the time, then of course it's suggestible to just quickly go through and use your Pythagoras theorem question to solve. But that is our questions. Thank you for listening. And if you have any more questions or you're looking for more questions or more help, I would suggest going on to the Altus One Education website and then going from there. Thank you, and I hope this was useful.